Welcome back. Let me explain why CC amplifier is called as buffer amplifier. Okay. If you observe clearly, solving the problem, studying the theory, understanding the limitation or advantages, then trying to compare with next circuit. Therefore, this is what is going to give you link between one concept to another concept. Not only understanding a concept, we should have the link, conceptual link from one topic to another topic. Then only we can remember the subject, else it is difficult to remember. The best way to remember complete subject is to have the link from one topic to another topic. Okay. Now, what is like before that, maybe what is buffer amplifier? I'll come to the amplifier section, but before that, let me ask you something from network analysis. Okay. Let me take small example to explain. Example is problem number 1, what it may be. Now, let us say there is a battery, right, which is practical voltage source, practical battery. Let us say this is 10 volt battery and having internal resistance 1 ohm. This is what is your battery. Okay. Now, let us say this is black box. Yes, it is a battery, but it is a black box. We don't know what is there inside, but equivalently using electrical domain, we are representing like this. What I'm saying, let us say this is what is your battery. This is what is your battery. Having 2 terminals, just 2 terminals, right? That's it. We don't bother what is there inside. But electrical domain, from electrical domain, I'm not speaking chemical domain or mechanical domain. I'm speaking electrical domain. Electrical domain is nothing but it is a practical voltage source. We have 10 volts and then 1 ohm, let us say. But how to find whether it is practical or ideal? Okay. Now, that is different. Now, this is what your voltage source. Now, what to do? You want to find what is the volt, but you know that it is a voltage source. You want to find what is the value of the voltage source. What to do? I'm giving you a battery. Then, I'm not saying what is the battery voltage. Then what will you do to find the battery voltage? You will take voltmeter. Yes, take voltmeter, connect voltmeter here or connect voltmeter across the battery. How much voltage it shows, that is what you say, that is what is the voltage of the battery. Now tell me, if you take voltmeter and connect, therefore if I put voltmeter and connect, but before connecting, if you know what is there inside in electrical domain, tell me what will be the voltage you get across open terminals. There is no load, there is no current. If there is no current, this entire voltage 10 volts you will get here. The same thing will be measured by your voltmeter. Therefore, if you take your voltmeter, this is what your voltmeter will give you 10 volts. This is what is 10 volts. Right? Then you will decide that this is what is going to give you 10 volt, means it is 10 volt battery. That is what you will understand. Right? Now, this is what is the same thing. Now, this is case A. Now, case B or case 2. Now, you decided that it is a 10 volt battery. Then, you are giving it to a bulb. You want to connect the battery to a bulb. Bulb is nothing but it has some resistance, let us say. Then you are connecting resistor. Then tell me. And this is what is a 10 volt battery. And this is what is the internal resistance, 1 ohm. Right? Now, this battery is used to connect a bulb, right? if a bulb is connected, this is what is the bulb which is giving light. A bulb is connected. Let us say the value of the bulb is this is what is having the resistance, which is load resistance. People represent like RL. Let us say that RL is equal to some 10 ohm. RL is equal to 10 ohm. Then tell me, what is the voltage? Means if RL is equal to 10 ohm, then what is the voltage? This is what is your output voltage. Let us say this is what is your output voltage from the battery. What are we expecting? We are expecting it to be 10 volts. That is what we got from voltmeter. The same thing I am expecting, and the same voltage will be applied to your load of 10 ohm, which is your bulb. But strictly speaking, if you consider the internal resistance, what is V0? V0 is nothing but, right, 10 ohm divided by 10 plus 1, 11 into 10, which is basically 10 into 10, 100. It is 100 divided by 11. Therefore, you will get approximately 9 volt. But what are we expecting? We are expecting it to be 10 volts. That is what you decided using voltmeter. But if you connect actual load, remember your voltmeter is not a load. Whatever voltage it is present from open terminals, it will just measure because it has internally infinity resistance. That is what is voltmeter, because your voltmeter should not disturb the state of the nodes, right? Therefore, it should have internally infinity resistance, but it has to measure whatever voltage which is what is present across the terminals. Now, here, if you connect actual load, your V0 became 9. And that too, let me tell you, if you change the load, your V0 also will change. Therefore, this is load dependent voltage you are getting at the output because it is a practical voltage source. That is what is your practical voltage source, which is not acceptable. Remember, if you want constant voltage for any circuit, then and that voltage whatever you are giving from the source, if load is different and the voltage what you are applying to the load is different, that is not acceptable. That is the reason why we need something called buffer in between. What is the job of the buffer? Therefore, here this is not acceptable. Cross means not acceptable. Not acceptable. Then what is the solution? If this is not acceptable, what is the solution? Case 3, solution. Solution to do not see. This is what is called, remember, this is what is called loading effect. This is what is called loading effect. This is what people say, right? Loading effect, because your load is affecting your output voltage. Therefore, this is what is called loading effect. But I explained using network analysis, like taking a voltage source and all. The same thing can be carry forward for your amplifiers, etc. Okay. Okay. What it may be, I'll go to that part and then explain what is buffer amplifier. But here, what is the solution? Solution is whatever battery you are having, right, and whatever internal resistance you have. Therefore, this is what is our practical voltage source, right? Then, if you are able to connect a buffer in the sense, let us say this is what is buffer, a digital buffer, some analog buffer, whatever it may be, you are connecting a buffer. Actually, if you ask me, this is nothing but op-amp buffer amplifier, something like that. Therefore, this is what is your buffer. When I say, means why it is called buffer, I'll tell you. Therefore, now connect the load. This is what is your bulb. Now, you are connecting a bulb. And this is what is having RL, the load value is equal to 10 ohm. Right? Now, let us see what is the output voltage to bulb. This is what your voltage, the bulb. Okay? Now, what is the action of the buffer? Okay? And let us say the buffer voltage gain. Let us say the voltage gain of the buffer. Voltage gain in the sense, it passes as it is. Buffer is nothing but buffering. Therefore, the voltage gain, let us say that is what is 1. And the input impedance, let us say is almost infinity or very high, okay, and then output impedance is almost 0, and this is almost infinity, very high or very low, right? Now, Having these things, let's see what is our V0. Okay, now tell me, earlier the load is directly connected to your source. Earlier the load is directly connected to your source, but now the load is not directly interacting with the source, right? And source is not directly interacting to the load. There is something in between, which is what is doing isolation. Isolation is nothing but separating both of them, and there is no effect from each other. Therefore, this is not affecting your source. Source will not affect your load. Indirectly, we are trying to avoid loading effect. The load effect is not there on the source, or the source effect, which is because of 1 ohm, is not there on the load. Let's see how. Tell me. Therefore, with respect to your actual source, what is the load for your source? The input impedance of your buffer amplifier or buffer circuit. Can I say that? But what is input impedance of your buffer amplifier? That is infinity, right? If you take your CC amplifier, what is input impedance? 400 kilo ohm. That is what we got. I can treat it as very high, take it as almost infinity with respect to 1 ohm, right? Then tell me, if it is infinity, can I say it is open circuit? If you treat this as open circuit, then tell me it is as equivalent to doing or open terminal, measuring open terminal voltage, right? Therefore, tell me what is open terminal voltage? Your open terminal voltage. Therefore, this is what when I say your VI, the input voltage to your buffer amplifier, and then V0, which is output voltage to buffer amplifier. Therefore, this is nothing but what? VI. Your VI is equal to 10 volts. Why VI is equal to 10 volts? Because input impedance is infinity. If input impedance is infinity, it is like open circuit. Therefore, it is as if the battery, which is what is connected and then not connected anything, and it is infinity. Then if you ask me VI, this VI open terminal voltage, that is what is 10 volts. This is 10 volt battery and this is what is 1 ohm, right? Now, what is the job of the buffer? It will not do any amplification. It is not doing any amplification. Because what is voltage gain? That is 1. Then what is it doing? Whatever you have here, the same 10 volts is given to your output. That's it. Because voltage gain is 1. Right? Now, tell me, for your source, for your load, we source. Battery is not the source now. Your buffer is the source for your load. Can I say that? Then, I told your buffer is nothing but voltage source to your load. Then, the buffer should be ideal voltage source. But what is output impedance of your buffer? Let us say R0. If R0 is equal to 0, then tell me, whatever voltage you have from the battery, the same voltage you can apply to your load, right? Maybe in this example, because I have taken 10 ohm, and then if you take R0 0, that is fine. But ideally, R0 should be very much less than RL. If you take audio amplifier or if you take actual circuits, in the case of CC amplifier and all, the load is not of 10 kilo ohm, right? And the output impedance of your CC amplifier is 40 ohm, then the 40 ohm is very less with respect to 10K, then indirectly we have proper impedance matching. Then the whatever voltage you are getting from your CC amplifier, that can be given to your load. In this scenario, because your load is 10, R0 should not be 40. If R0 is 40, remember, again there is no impedance matching. Your R0 should be very much less than 10. You can say 0.1 ohm, 0.2 ohm, 0.3 ohm, then only you can say we have proper impedance matching. I am assuming R0 0 because I am explaining generic case but trying to compare or correlate to your CC amplifier. Therefore, when I say this is what your buffer amplifier having AV is equal to 1, RI is infinity, R0 is 0, then it is simply voltage source for your load, then your V0 will be equal to as it is because V0 AV is equal to 1, then what is your V0? Your V0 is equal to 10. You know, this is as if, therefore this is nothing but overall if you ask me, this is equivalent to a battery, it is equivalent to a battery of 10 volts connected to load directly. Load is nothing but, let us say, the bulb. This is what is our bulb. Then what is this voltage? Therefore now V0 is equal to the 10 volts battery. This is equivalent. Remember, physically this is not the case. Physically we have practical voltage source. Physically we have bulb. If you connect physically, we are getting V0 9 volt, which is not acceptable. But when you keep buffer in between, it is isolating both source and load, then we are getting equivalently the battery, ideal battery is connected to load. That is what is the job of your buffer amplifier. Remember it is not giving any voltage gain. You may say that, no, I don't have voltage gain, why do I use it as an amplifier? Now I am not using it as an amplifier, I am using it as an isolation circuit or buffer amplifier. I hope everybody understood the purpose of buffer amplifier, which is what is avoiding loading effect, and I can say the source is also not ideal or source is also practical, it is avoiding the source effect also. Okay, take it. The same thing I am going to explain in the case of your amplifiers, and I will give you the block diagram. Okay, take it. Therefore, everybody will have their own specialty. Your CE amplifier is having voltage gain, but no impedance matching. Therefore, it is having specialty with respect to voltage gain or power gain. But if you take CC amplifier, its specialty, what is its specialty? It has very good impedance matching, but no voltage gain. But it has specialty of avoiding loading effect as well as source effect, because it is buffering or isolating both the circuit, even though it doesn't have voltage gain. Okay. Therefore, we are going to take the specialty of each circuit. Therefore, from CC amplifier, impedance matching. From CE amplifier, voltage gain. If you combine, you will get best amplifier. See, slowly we are trying to get op-amp internal block diagram. Right? Take it. Maybe if you ask me the heading, this is without load. And this is with real load. Now that is the solution. That's why maybe if you see any circuits, maybe your mini projects and all, before giving the actual load, normally people put op-amp buffer amplifier, because the load should not affect your actual circuit, source circuit, right? If you put buffer in between, it is isolating. Wherever you want isolation, simply put buffer amplifier. It will take the job. I'll wait for 1 more minute and then I'll start. Okay. Over? Okay. Now, I think everyone understood the meaning of buffer action, right? This is what is your buffer action. Now, write down conclusion from both CE and then CC amplifiers. Okay. Conclusion. First point, actually under conclusion I'll give observation and then conclusion. Okay, but finally conclusion. First point, CE amplifier is providing very good voltage gain. CE amplifier is providing very good voltage gain, but there is no impedance matching. For voltage amplification. CE amplifier is providing very good voltage gain, but there is no impedance matching for voltage amplification. Continuation. CC amplifier is providing very good impedance matching. CC amplifier is providing very good impedance matching for voltage amplification. CC amplifier is providing very good impedance matching for voltage amplification. CC amplifier is providing very good impedance matching for voltage amplification, but voltage gain is unity. Next point, the second point, let us combine both CE and CC amplifiers. Let us combine both CE and CC amplifiers. Let us combine both CE and CC amplifiers to extract voltage gain from CE amplifier, to extract voltage gain from CE amplifier, and impedance matching both at input and output. Impedance matching both at input and output. Impedance matching both at input and output. Impedance matching both at input and output from CC amplifiers. From CC amplifiers. From CC amplifiers. Okay? Whatever I told, the second point, let me give you the block diagram. Therefore, just listen, later on you can write, I'll give you time. Now if you take CE amplifier, maybe you can go at multi-stage CE amplifier, CE amplifier 1, CE amplifier 2, to have more and more gain. I told you already, ultimately I want to have op-amp block diagram. To get op-amp block diagram or op-amp internal circuit, right? The things what we need, I'm just trending towards it and covering the syllabus and solving the problems, right? But ultimate goal is to have op-amp circuit, ultimately voltage amplifier. But along with that voltage amplifier, we need to study other parts to understand and to cover the syllabus as well. Okay, that's fine. Now this is what is our CE amplifier, multi-stage CE amplifier or CE amplifier, that is fine. Therefore, if you have multi-stage CE amplifier, whatever gain you have, that is what we want to extract, right? That is what your CE amplifier, and let us put CC amplifier in between, which is basically your buffer action. Therefore, this is what your CC amplifier. That output is connected to input and the reference is always ground. I'm not showing. It's like node voltages or terminal voltages. Okay, single-ended voltages. Other thing is ground. Okay. Now this is what is our CC amplifier. This is also called buffer amplifier. Therefore, we are connecting CC amplifiers both at input and output because we want input impedance matching, output impedance matching also. Okay. And this is what your circuit. And now let us say this is what your actual source. This is actual source. Now this is Vs. Now let us say Rs is equal to 1 kilo ohm. And now let us say this is what is the load. Now RL is equal to 10 kilo ohm. And this is what is your V0. Now we want to know what is V0. Okay. This is what is our block diagram. Let us say this is what is our block diagram. Okay. Now maybe let us represent the AC parameters whatever we calculated individually, right? Therefore, let me take what is voltage gain. Voltage gain of CC amplifier is approximately equal to 1. Voltage gain of CC amplifier is also approximately equal to 1. And voltage gain of CE amplifier, let me take it as AV. Let me take it as AV, right? That is what is voltage gain from your CE amplifier. And what is input impedance, right? Tell me, I'm just using whatever we calculated. Therefore, what is input impedance of CC amplifier? We calculated that to be 400 kilo ohm. And what is output impedance of CC amplifier? We calculated that to be with 40 ohm, right? Therefore, now can I say, and this is what is your input voltage. This is what is your input voltage. Just listen, okay? Now, tell me, with respect to source, tell me earlier, the source is directly connected to your CE amplifier. Actually, if I say this is what is my interested amplifier which is to be connected to your source, therefore it will amplify because this is what is providing your voltage gain. Then earlier, if you take CE configuration, we just gave VSRS directly over CE amplifier, but the input impedance of CE amplifier is 1 kilo ohm, right? the input impedance of CE amplifier, Ri, that is 1 kilo ohm, right? And this is what is providing voltage gain AV, okay? Now this is what is Ri is equal to 1 kilo ohm, right? And R naught, we got 52 kilo ohm. I'm just using, but let me tell you one point. Ri will change because what is load for CE amplifier? Earlier the load was 10K, but now load was input impedance of CC amplifier is the load. Therefore now the load for CE amplifier is not 10K. Now the load for CE amplifier is input impedance of CC amplifier. Then whatever we calculated, current gain, input impedance, voltage gain, they will change. But I'm not calculating all those things. Anyway, you know the procedure. And if you know RL, if you know RS, we know how to solve all those things. But I'm not explaining now the problems. I'm explaining the theory. Therefore, I'm just taking the values as it is, whatever we calculated, but strictly speaking, they are not true. That's why instead of saying 1K, let me say in the order of 1K, 52K, because the load for CE amplifier is now not RL, input impedance of CC amplifier. The source for CE amplifier is not now RS, the output impedance of CC amplifier. That's why R0 is different, R is also different. But I'm taking the values just to explain the theory, whatever we calculated. That's why I'm saying approximately. Okay, done. Therefore, now tell me, with respect to the source. With respect to the source, now CE amplifier input impedance is not the source, sorry, not the load. CC amplifier input impedance is the load. Therefore, indirectly this is what is isolating your CE amplifier and then source. Therefore, this is what is doing the buffer action. It is isolating CE amplifier input and your source input. Earlier 1K, half of the voltage is dropped, only Vs by 2 is applied to your amplifier. Now because of CC amplifier, which is what is present in between, it is acting as an isolation amplifier or buffer amplifier. Now what is it doing? Ri is 400K, which is very high. When Ri is 400K, then this is 1K, then the interaction between these two, I can say Ri is infinity. When Ri is infinity, then what is your Vi? Then it is infinity, it is like open circuit. Open circuit, there is no current entering into amplifier. If there is no current entering into amplifier, there is no drop across 1K, then this Vs will be coming here. Therefore, what is your Vi? Your Vi is equal to Vs. Your Vi is equal to Vs. Indirectly, if you observe or not, I explained for a voltage amplifier requirement. Therefore, I am not able to improve Ri, right? I am not able to improve Ri, but indirectly, you know, we are able to improve the source. Source in the sense, the source for your common emitter amplifier. Now the source for your common emitter amplifier is nothing but your CC amplifier. But what is CC amplifier output impedance? 40 ohm. What is 40 ohm with respect to 1K? That is very much lesser, at least 25 times. If it is 10 times also, people take it as high or low, okay? Therefore, now this is lower value, we can take it as approximately 0. Your CC amplifier is the source for your CE amplifier, and then having the voltage, which is nothing but voltage gain is 1, then whatever voltage you have, the same voltage you get here. Therefore, what is the voltage now you are giving here? That is approximately equal to Vs. Therefore, with respect to CE amplifier, indirectly we are exciting with ideal voltage source. That is what is because of CC amplifier or buffer amplifier. That is what I told in the example, right? Just before this, I gave you an example by inserting buffer in between. Indirectly, the practical voltage source is becoming ideal voltage source, right? I'm not improving Ri. I'm not increasing Ri. Remember, indirectly, I'm changing the source. Equivalently, I'm changing the source for your CE amplifier such that the source is becoming ideal, exciting with ideal voltage source. Fantastic, right? But what is that? Is because of what? It is because of your CC amplifier. Even though CC amplifier is not giving any voltage gain, but it is doing the interaction, and that is helping us to utilize the overall voltage gain from your CE amplifier, and we are getting overall improvement in the gain. Even though directly it is not giving voltage gain, but that is helping to get overall gain from your system. That is the purpose of buffer amplifier or isolation amplifier. Okay, I hope this is clear. That's why I gave the example and before this, and then we are going to your amplifier structure or your multi-stage amplifiers. Now coming to your CE amplifier. Now whatever signal which you are applying at the input of CE amplifier, it will amplify with a gain of AV into Vs. That is what is your output voltage. Now, but are we getting AB into VS, or is CE amplifier giving AB into VS directly to CC amplifier? That depends on again load interaction, because it is a voltage source for your CC amplifier. Remember earlier the CE amplifier is directly connected to your loudspeaker or load. Now we are inserting something in between, which is what is acting as a buffer amplifier or isolation amplifier, which is isolating both your CE amplifier and the load. Now how is it doing, or how is it helping, right? Let's see. What is input impedance of CC amplifier? Your input impedance of CC amplifier, Ri, that is, let us say 400 kilo ohm. And what is output impedance of CC amplifier? Right, these are all close to, okay. Then what is output impedance of CC amplifier? 40 ohm, right? Therefore, now tell me, therefore, this is nothing but, this is your CE amplifier. Now, it has output impedance which is R0. Then it is load, which is, now what is the load for CE amplifier? Input impedance of CC amplifier is nothing but the load, because this is what is driving CC amplifier, not your RL. When this is driving your CC amplifier, the load is 400K. What is 400K, 52K? Your R0 is less than 400K, but not very much lesser than 400K, but 8 times approximately. But you can treat it as approximately 8 times, okay? Then 52K to 400K, therefore load is very high. Then the drop across the internal R0 of our CE amplifier, if you treat like a voltage source, then that can be neglected. Entire voltage whatever you are getting, which is AB into VS, will be applied to your CC amplifier. I can say approximately, but less than, because the relation is not too much. But what may some drop will be there, but what may be AB into VS, almost entire voltage will get it. Almost entire voltage will get it. And if you observe, I am not taking AB is equal to minus 400, which we got from CE amplifier, because that AB is equal to minus 400 with the load of 10K. But now the load is 400K. Now the voltage gain will improve like anything. It will improve like anything, right? It is increased because of CC amplifier. That's why I am not saying 400. It is very high. Okay, it will be not of 2000, 3000, right? You can say in that way. Not, sorry, it's not 2000, 3000. It will be 500 to 1000. Now, when I say AB into VS, then it is given to CC amplifier. What is CC amplifier voltage gain? 1. AB into VS into 1 is nothing but output voltage. And for your load, what is the source? CC amplifier is the source, not CE amplifier. Therefore, CC amplifier output impedance is 40 ohm. With respect to 10K, the drop across that internal 40 ohm can be neglected. That AB into this input will be given to your V0. AB is nothing but 1 into AB into VS. That is what is given to your V0. Therefore, your V0 is equal to AB into VS. Overall, if you ask me, this is as good as, I don't have space, but if you have space, equivalently you can represent. Therefore, this is what is equivalently exciting with ideal voltage source at the input, and this is directly given to CE amplifier, right? And whatever load you have, right? The load here, as if there is no load. Then if there is no load, entire voltage what you have from CE amplifier will be given, right? Therefore, as if this is what is equivalent to whatever load you have connected. Let us say this is your actual load, 10 kilo ohm, and this is your V0, and this is what your VS. Now here indirectly the Ri of your CE amplifier is infinity, and then R0 of CE amplifier is equal to 0. Indirectly with respect to source and then load, indirectly this is what is having infinity resistance, and this, sorry, indirectly this is what is having infinity resistance. This is your VS and then RS. Therefore, what it may be your V0, and then overall gain, if you say this is AV is equal to V0 is equal to AV into VS only. Directly this VS is coming. Even though your source is practical, but you are taking only VS. Here indirectly taking out the impact of RS. That is because of Ri infinity, right? Therefore, this is what is your ideal CE amplifier. Indirectly we are making. But remember, this is not physical. The physical CE amplifier is this. But because of CC amplifier both at input and output, indirectly Ri of CE amplifier is infinity, R0 of CE amplifier is 0. Then this is what is interacting with respect to the load, you take this. That's why if you take your op amp slowly, you'll understand. Now if you open the op amp block diagram, you will understand the first stage and the last stage of your op amp, because we need input impedance infinity, output impedance 0 for voltage amplifier. That we can get it right by using CC amplifier. Very easy. That's why the op amp input circuit and then output circuit, they are from CC amplifiers only. Okay. But I need to add one more thing before then we can correlate with respect to op amp. That is what it is. Okay. Here this is nothing but Vi is equal to Vs, because Ri is infinity, there is no current, then there is no drop across Rs. The drop across Rs is 0. Similarly, there is no drop, internal drop, because of output impedance from your C amplifier. Entire voltage is applied to your load. See, even though we have one advantage from one circuit and another advantage from another circuit, as a designer, right, we can combine and to get whatever you want. But the thing is, area will increase and power will increase. Whatever it may be, ultimately performance is important, right? But when you compare with the digital circuits, the number of transistors occupied in analog circuits very less, which is very minute. If you just take one flip-flop, one D flip-flop, right? Using one D flip-flop, how much? It will store only one bit of information. Just to store one bit of information, and remember not to process. Just to store one bit of information, if you need some, let us say some 50 transistors. Here, maybe if you take your op amp is nothing but your generic amplifier having voltage gain very high or infinity, input impedance infinity, output impedance 0, right? That needs only in the order of maybe if you compare, maybe less than 50. Okay, but if you add remaining things, like if you take IC 741 op amp, internal circuit which has offset cancellation, calibration, right? And if you include everything, right, and then biasing circuit, etc., there are 108 transistors, approximately 108 transistors. But whatever it may be, if you don't want all those offset cancellation or calibration or biasing and all, simply if you want to get gain and then input impedance, output impedance, remember using 11 transistors, or I can say 12 transistors, we can get very good amplifier which will process the signal, which will process the analog signal. But a D flip-flop, it will store the signal, it will not process. But analog circuit, it will process, but it cannot store. Okay, what it may be, processing needs only a few number of transistors, but in the case of digital, storage needs those many transistors. Then for processing, how many transistors you need? You need more number of transistors. With respect to digital, the number of transistors taken in the analog circuits, I can say very less. Okay, but analog circuits are complex. Digital circuits are easier because we deal with teeny entities like gates, logic gates. Here we deal with amplifiers. Using amplifiers, we'll get different circuits. I hope this is clear. See, ultimately I want voltage amplifier. That is the reason why we are changing the configuration or improving the configuration such that we are trying to get V0 is equal to maximum voltage gain into your Vs. Okay. Remember, if you want to get current amplifier also we can get it, but practically nobody is asking for current amplifier, everybody is asking for voltage amplifier. Okay. I can say this is over. Now maybe little improvement if you want, we can do it. That is what is done in the case of op amp. That's why I'm not saying this is the block diagram of op amp, because there is some improvement. See, what is your RI from your CC amplifier? We got approximately 400 kilo ohm, right? Let us say source is 1K, then 400K is very good enough. Let us say there are some sources, if you take RS 100 kilo ohm. If the source resistance is in the order of 100 kilo ohm, then if RS is in the order of 100 kilo ohm, then 400 kilo ohm is also comparable, right? Therefore, to improve my input impedance further, and I want input impedance in the order of mega ohm. If I want input impedance in the order of mega ohm, single stage CC amplifier is not enough, then people go ahead with two-stage CC amplifiers, which will give you the input impedance in the order of mega ohm. Okay. Therefore, let's see what is that two-stage CC amplifier. People call that as Darlington pair. Just it is a name, but if you ask me with respect to multi-stage configuration, two CC amplifiers. First CC amplifier output is connected to second stage CC amplifier input. Therefore, it is CC amplifier, two CC amplifier stages. Therefore, Darlington pair. Therefore, the third problem, the workbook problem, the third problem is related to Darlington pair, even though it is showing some circuit with respect to two transistors, but let me tell you that is nothing but two-stage CC amplifier circuit, which is Darlington pair circuit. The basic motivation for going for that circuit is to have to improve the input impedance further. I want input impedance very high, not in the order of hundreds of kilo ohm, I want in the order of mega ohm. Okay. Therefore, in the next session, we will see problem number 3, right, which is nothing but Darlington pair. The motto is to improve the input impedance. But what it may be, let's treat it as a problem. If you treat it as a problem, we need to calculate all AC parameters for the circuit. Okay. Then let's solve all those things and then let's see the theory related to it. Okay. If you understand solving the problem, understanding the theory. Solving the problem, understanding the theory. Link these two concepts. One more circuit, theory, link these three circuits. Therefore, linking is very important. Okay. Let me stop now. Then we will continue from problem number 3 from the next class. Thank you.